Welcome to Math 2320, Section 4.2. In this section, we begin to look at second order differential equation. It is homogeneous. There is no driving function. We have a function p of x multiplied by y prime, and q of x is multiplied by y. So what we are given is a differential equation. So sitting here, we are given one solution. And so we're trying to find a second solution. And the second solution is given by this formula, where the second solution is y1, my first solution, times this integral. It's fairly recipe-ish, so let's take a look. So first off, I need p of x. Well, p of x is in front of y prime here. So that's minus 4. Integral of minus 4 is minus 4x. E to the minus that integral. Now the only danger there is don't mess up the double minus. So I get e to the 4x. So I've got e to the 4x over y1 squared. Well, y1 is e to the 2x. And e to the 2x times e to the 2x is the exponents add. 2x plus 2x is 4x. And those cancel and we get a 1. So in actuality, I'm integrating 1. And when I integrate 1, I get x. And so my second solution is the first one, which is e to the 2x times this integral. So this was e to the 2x, and this whole integral turned out to be x. Okay, so let's see. Question 2. Question 2, we are given this differential equation with, again, a solution, and I want to find a second one. Well, the first thing is I'm looking for p of x. Well, p of x is in front of y prime. It's missing, so it's 0. And so the integral is 0. E to the 0 is 1. And so I've got 1 for this piece. What's on the bottom? Well, my one solution is cosine of 6x, so that's squared. I've got 1 over cosine squared, and 1 over cosine is secant. So I've got secant squared of 6x. All right, so this becomes I've got the top part, which is secant squared, over y1 squared, which is cosine squared. And if you simplify that and you integrate, we get integral of secant squared is 1/6 tangent of 6x. Alright, so the simplification comes here when I plug in y1. y1 is cosine. This part was the integral of secant squared, which is my tangent. Cosines cancel, and so I get 1/6 the sine of 6x. You don't have to worry about the 1/6 because that would be absorbed into our two constants, c1 and c2, and so this is just the sine of 6x. All right, in our last question here, we have our second order problem. It is non-homogeneous. Why? Well, the right hand side is not 0. So they're giving us one solution. We want to find another solution. All right, once we do that, we would like to guess a particular solution for the non-homogeneous case. So y2 goes for the homogeneous. Let's see, where's p? P is in front of y prime, so that's the integral of 1. So integral of 1 is x, and so I get e to the minus x. So this is e to the minus x over y1 squared. Well, what was y1? Y1 is 1, all right, so this whole business is e to the minus x. All right, so we need to have y1 times the integral of e to the minus x. Well, the integral of e to the minus x is this piece, so there's my integral. This piece is y1, and so I get minus e to the minus x. And so that's my second solution. And again, I don't have to worry about the constant in the front because that would be taken care of later. And so the only thing left is I want to guess a particular solution to the non-homogeneous problem. Well, if you look at it for a little bit, what do we need? We basically need y double prime to be 0, and I need y prime to be 1. So a real easy, simple guess is let our particular solution be y particular of x is just x. Because second derivative is 0, first derivative is 1, and 1 equals 1.